Hello everyone, I'm Vishruth Ramesh, currently pursuing my computer science engineering in Sri Venkateswara College of Engineering, and today I'm going to be presenting on the topic Embedded Systems Hardware. What is an embedded system? As its name suggests, embedded means something that is attached to another thing. An embedded system can be thought of as a computer hardware system having software embedded in it. An embedded system can be an independent system or it can be part of a large system. An embedded system is a microcontroller or microprocessor-based system which is designed to perform a specific task. So we can define an embedded system as a microcontroller-based, software-driven, reliable, and a real-time control system. Hardware components of an embedded system. Power supply. The power supply is a key component to provide the power to the embedded system circuit. The power supply is selected as per user requirements and application requirements. Processor. The processor acts as the brain of the system. The processor is responsible for deciding the performance of the embedded system. Memory. It is used to store the data and the programs. Timer counters. Used to provide a delay in the application. Communication ports. It is an interface that is used to communicate with other types of embedded systems. Output and input. These are ports which are used to interact with the system. Circuits used in the application. The embedded system requires hardware components that can be used for design purposes. The selection of the circuit is completely dependent on the application used for the embedded systems. For example, a temperature sensor. This is the basic layout of the embedded system's hardware. It consists of an ARM processor, the different controllers such as interrupt controller, AHB arbiter, memory controller, AHB external bridge, and an AHB APB bridge. It also consists of peripherals such as real-time clock, serial UARTs, Ethernet, counter/timers. The ARM, the controllers, and the peripherals are interconnected by bus. The serial UARTs is connected externally to a console, the Ethernet to an Ethernet physical driver, the AHB external bus to an external bus which connects to a ROM, SRAM, and a flash ROM, also a DRAM. The ARM processor. It controls the embedded device. An ARM processor comprises of a core, the execution engine that processes instructions and manipulates data, and the surrounding components that interface it with the bus. Controllers. Helps coordinate important functional blocks of the system. Two commonly found controllers are interrupt controller and memory controllers. Peripherals. Provides input-output capability external to the chip. Includes serial input-output, parallel input-output, timers, counters, and clock circuits. Bus. Supports communication between different parts of the device. The ARM bus technology. The embedded devices use an on-chip bus that is internal to the chip and that allows different peripheral devices to be interconnected with an ARM core. There are two different classes of devices attached to the ARM on-chip bus. A bus master. A logical device capable of initiating a data transfer with another device across the same time. The ARM processor core is a bus master. Bus slaves. Logical devices capable only of responding to a transfer request from a bus master device. All peripherals are bus slaves. On-chip ARM has two architecture levels. Physical level covers the electrical characteristics and bus width, that is 16, 32, or 64 bits. Protocol level covers the logical rules that govern the communication between the processor and a peripheral. The Advanced Microcontroller Bus Architecture, also called as AMBA bus protocol. It was introduced in 1996 and widely adopted as the on-chip bus architecture used for ARM processors. The first AMBA buses introduced were the ARM System Bus, ASB, ARM Peripheral Bus, also called as APB. Later, ARM introduced another bus design called ARM High Performance Bus, AHB. A peripheral can simply be bolted onto the on-chip bus without having to redesign an interface for each different processor architecture. The AHB provides higher data throughput than ASB because AHB is based on a centralized multiplexed bus scheme, ASB bidirectional bus design. ARM has introduced two variations on the AHB bus, multi-layer AHB and an AHB Lite. The original AHB was allowing a single bus master to be active on the bus at any time. The multi-layer AHB bus allows multiple active bus masters. The AHB light is a subset of the AHB bus and it is limited to a single bus master. AHB light was developed for designs that do not require the full features of the standard AHB bus. Memory. An embedded system requires some form of memory to store and execute code. The memory should be fast, large, and inexpensive. Unfortunately, it is impossible to meet all the three requirements. So the common solution is to have the memory hierarchy. The memory width. The memory width is the number of bits the memory returns on each axis, which is typically 8, 16, 32, or 64 bits. The memory width has a direct effect on the overall performance of the system. This table summarizes the theoretical cycle times on an ARM processor using off-memory width devices. The instruction size ARM32 in an 8-bit memory has 4 cycles, in a 16-bit memory has 2 cycles, in a 32-bit memory has 1 cycle. The thumb 16-bit in an 8-bit memory has 2 cycles, in a 16-bit memory it has 1 cycle, in a 32-bit memory it has a 1 cycle. The peripherals. The embedded systems communicate with the outside world via peripheral devices. A peripheral device performs input and output functions for the chip by connecting to other devices or sensors that are off-chip. Each peripheral device usually performs a single function and may reside on chip. Peripherals range from a simple serial communication device to a more complex 802.11 wireless device. Controllers. Controllers are specialized peripherals that are found within an embedded system. Two important types of controllers are memory controllers. Connects different types of memories to the processor bus. On power up, the memory controller activates certain memory devices to execute initialization code. Interrupt controllers. When a peripheral or device requires attention, it sends an interrupt to the processor. There are two types of interrupt controller in an ARM processor. The standard interrupt controller, SIC, sends an interrupt signal to the processor core when an external device requests servicing. The interrupt handler determines which device requires servicing by reading a device bitmap register in the interrupt controller. The vectored interrupt controller, VIC, provides more functionality than the SIC. Along with the masking functionality, it also provides the functionality to prioritize the interrupts. Thank you everyone. I really hope you understood all the concepts I covered in this video. I really hope you like and share this video. Thank you.